Hello, this is Ryan Woodward recording a video for Intel's Digital Logic course. This is Lab 4 Part 1, and it's going to be Part 1 of 2, partly because it's been taking me a long time to kind of dust the cobwebs out while I'm relearning VHDL or Verilog. A lot of it came back pretty quick, so I'm glad for that, but I haven't spent any time on this course in probably the last 6 or 7 months, and so it's nice to be able to actually get to return to it and begin again. But regarding Lab 4 Part 1, I have spent a lot of time trying to figure out why my T flip-flop counters would not work quite properly. And I've borrowed T flip-flop code off of the internet. I have derived my own code at times. I've tried to research and understand more to the best of my ability. I've even used a JK flip-flop and created a whole different component based off of that, and so on, and yet I have not been able to get a counter that works properly as designed past 3 bits. And I found this a lot on the internet as well. There's a lot of T flip-flop counters, asynchronous, synchronous, up or down counter, that do not work past 3 bits, and that has been a problem trying to figure out a lot of those things. But this is where I have landed. I have, for the most part, the counting seems to work. It will skip numbers at times, but it seems to work generally, and I'm going to be happy with that simply because I have already spent a great deal of hours on a course that I'm not paying for, and it's really not that relevant that I'm doing it. So because it's a personal passion, that's why I'm continuing along with it. But to begin, here is the T flip-flop logic. I've declared a few inputs and a single output, which is our Q LED. I didn't bother with a QB LED, but we have a T switch. This is our T value. We have our clock button, and then we have a reset switch for when we want to actually reset the values. And because the switches aren't debounced, it actually allows me to use it that way, the reset switch. But from there, it's a very simple process of actually creating this T flip-flop. We put in our sensitivity list here the clock button, the T input, and the reset input. If reset is 1, then temporary, this intermediate signal here will be 0, and that ultimately is what gets passed to the Q LED output. If the reset switch is not 0, or not 1, excuse me, then we begin to check the clock. On the clock button falling edge, we will check if the T is 0. Then if it is 0, then the intermediate signal remains unchanged. That's what this does here. And if it is high, then we will invert to the intermediate signal and assign that to the intermediate signal, and that gets passed to QLED, and that's where we get that toggling T actual action from the LEDs. So, leveraging this, I created a component. I used a structural architecture here, although it says behavioral. I created 4 instances of T flip-flops, and I have followed this circuit diagram here. Now, this is only for 3, and it seems to work pretty well for 4 so far. I haven't tested it with 8 bits, but it seems to work okay for 4 bits. And although the lab says use a synchronous counter, I have not been able to get this to work properly with a synchronous counter. It's probably my code on my end, my inexperience, and so on, but this is the diagram I'm following, and this seems to work pretty well. Aside a general port mapping, I've declared an enable switch, which serves as T, a clock, a reset, and an array of, or a vector I guess, of LEDs for the 4-bit value that we will be displaying with the outputs of this circuit, this counter. And we can see that what's important is that Q1 this is the intermediate signal here, and that gets assigned the output, which eventually gets passed. That way there's a flow of as all the concurrent statements are running, there should be a small delay between which this is assigned and which this is assigned. Alright, that is the code for this part 1 of Lab 4, and I will attach a demo of this to the end of it. Thank you. Alright, so here is Lab 4, part 1 of 2. We have a T flip-flop, and it can actually count up I better flip it this way actually because I have the LEDs reversed. But we have our reset pin, this is the second one here, that's low, and T is currently high, and our clock button is right here. And so what we'll see is we'll see the LEDs increment from right to left to represent the counting. So to begin, we have 1, 2, 3, and then we see that the first LED moves to 4, but the second one does not move. And this is a common issue I've had with T flip-flops and counters. For whatever reason, I am not sure why that one wants to stay high. But we can continue to count. We've moved from 5, technically, to 6. Then we go to 7. And then it will be 8, but for whatever reason, that one stays high again. We'll move to 10, 11, 12. We're technically at 13, though. And then we'll move to 14 and 15. All right, and that's the demo. Oh, I'll show the reset at least. All right, there we go.